So this video is about the Arduino GIGA Display Shield, which is more than just a display with a lot of tech in it. And in this video, we're gonna see everything about it, starting from its specifications, how to use it with the Arduino IDE. We're testing out some example projects to test all the features of it. Then we'll having a look over how to use the LVGL library for making some interesting GUI based applications. And in the end, we'll be having a look over how to use the tiny GL library to construct and render 3D objects. So there's a lot to discuss, but let's start this video with a quick unboxing. So this is how you will receive the product in the standard Arduino packaging, with the image and the name of the product on the top and its specifications on the back. So now let's open it up. So below this cardboard, we get the actual display. Then below it, we get to see some paperwork along with the Arduino stickers. So that's what you get in the box. Now let's discuss about the specs of the shield. So this is a 3.97-inch display with a resolution of 800 by 480 pixels. It comes with a capacitive touchpad on the top that supports up to 5-finger touch and gestures. It do have a dedicated Arduino cam connector on the top, a PDM microphone near to it, and a tiny RGB LED for indication purpose. Then on the back, we get a BMI 270 IMU for all the motion-based projects. And all this comes with the size of just 106 by 80 mm. So those were the complete specifications of the display shield. Now let's jump on to Arduino IDE and test out some example projects. So first, let's start with the basic example to display our image on the screen. For that, you just need to go to Files, into Examples, then into Arduino H7 Video, and here just open up the example called as Arduino Logo. I'll maximize this example. And this example is used to display a logo of the size 300 by 300 pixel, and the logo file is provided here in the header file. So this is the hexadecimal format or the form of a JPEG image. Okay, so first let's try to upload this code and visualize what we are getting on screen. So here the right board and COM port is already selected. I'll straight away hit the upload button. Okay, so the code is uploaded and we are able to see an Arduino logo on the screen. So that was a simple example to display the image on the screen, and we can not only display the Arduino logo, but we can display any image that we want using this image converter tool. Okay, so let me show you how to display my own logo. Let's techiesms logo on the screen. For that, you just need to click on this link, which will open up this page on your web browser, and here you have to select the image. Now let's try to display the complete like 800 by 480 pixel image. And if you want to make that custom size image, well, you can use the free platform called as Canva, and here you can click on Create Design and select custom size. Now here you can provide the size that you want. In my case, it is 800 by 480 pixels. You can click on create new design, and here is the 800 by 480 canvas. Okay, now here you can click on the upload button to upload your own file, own image. I will drop this techiesms logo and I will arrange it to the maximum size possible. Perfect. So after confirming everything, I will click on the share button and click on the download button. Here I'll download it in the JPEG format and download. So we got our 800 by 480 pixel image. Now let us go back to that web page. Now here I'll select, click on the browse button. I'll select the file which I just downloaded, which is this, and here I'll select the output array as binary 565 and click on the convert button. Now with this, we got the binary version of this image file, but we want the hexadecimal version. For that, you need to go to this website, whose link I will provide in the description. Here click on choose file and select the binary file which you just downloaded. Click on the upload button, and here you got all the hexadecimal values of your image. Click on copy output to clipboard and just paste that here inside the Arduino logo.h header file. I'll paste that here. And now in the main code, we need to change the dimension. So here earlier it was 300 by 300, but this time it is 800 by 480 pixels, and the coordinates will be 0, 0 only. Okay, that's it. That's all changes you need to do in the code. Let's just hit the upload button and let's see what happens next. So the code is successfully uploaded and we got to see the techiesms logo printed in full screen. Okay, and that's how you can display any image that you want in this GIGA Display Shield. Then next up, let's test out the RGB LED on the display. Yes, there is a very small like RGB LED near to the microphone on this display, which you can use for the indication purpose. And to use this RGB LED, well, there is a very simple line of code provided in the official Arduino documentation page. I just copied that code and pasted it here, and this will make sure that the blue pixel in that RGB LED will turn on, and it will turn off all the pixels. That's a very basic Blink example code. So I'll straight away hit the upload button. Let's test it out. And also, to make this code work, you need to install this Arduino GIGA Display library, which you can easily download from the Manage Library section. Okay, so the code is successfully uploaded and the green LED turned on in my case. So let's just try to turn on the middle one and let's see if the blue LED turns on or not. Okay, it's done uploading, and this time the blue LED turned on. And let's try out the red LED as well, just to confirm everything. And it's uploaded, and this time the red LED turned on. So the sequence is red, blue and green rather than red, green, blue. I don't know why, but yeah, that was a simple code to use the RGB LED. Moving ahead with the next feature of this GIGA Display Shield is the microphone. So I do have a PDM microphone just near to the RGB LED, and they have provided some sample codes as well to test out the microphone. So first code is used to get the values of the microphone straight on the serial monitor or serial plotter. So let's test out that microphone code quickly. So I'll copy that code, I'll paste it here, and in this case you need to install this pdm.h like the library, which also you can get in the Manage Library section, and just download it straight away. And it says done uploading. Let's open the serial monitor. The baud rate is set to 9600, and yes, I'm getting a couple of response, but it's hard to visualize whether it is a garbage data or a proper data. Let's just try to open the serial plotter. Hello. Okay, so the microphone seems working. Let's just try out a very interesting testing of this microphone. So on my YouTube, like on my smartphone, I'm opening up a YouTube video that plays the frequency from the range 20 Hertz to 20,000 Hertz. Okay, let's play that file and observe the frequency response on the serial plotter. So I'm putting the microphone, like the phone, near to the microphone, and let's just test it out. Okay, so we are able to see the sine waves on the serial plotter, and slowly the frequency is increasing. It seems really good. So right now the frequency is 130 Hertz, 200 Hertz, 400 Hertz, 1000 Hertz, and the frequency is high now. It's 2.5 kilohertz. So that was the test of the microphone. So we were able to see the sinusoidal waves based upon different audio frequency. That means the mic is working, and that is one more interesting example provided by the Arduino community, which is kind of a clap switch that we used to make with the basic electronic circuits. And that same thing they have provided here. So I'll copy this code. Let's just try to upload this code and see what happens. Okay, so I'll straight away hit the upload button. Also, you need to have the Arduino graphics.h library, and all you can get in the same library manager. Okay, so the code is successfully uploaded. Okay, so it's blue, it's yellow, it's again yellow but a bit different shade. It's blue, orange, yellow, blue, orange, yellow. So the shades are changing based upon the clap, you can say. Okay, so that is also one of the way to test the microphone, but in a very interesting way. So that's how you can use the PDM microphone for your applications. Then moving on to the next example, which is regarding the IMU, or the inertial measurement unit, which is used to determine the orientation of the display. Okay, and to test out that, we do have an example code provided. So I will just copy this code and paste it here. Again, the one necessary library need to be installed. In my case, I already installed it, and I'll straight away hit the upload button. Now this code will let us know the X, Y, Z axis orientation based upon the movement of the display. As you can see, the X, Y, Z coordinates, or the axis, is shown on the serial monitor, and based upon the movement of the display, the values are changing. Okay, so that's how you can be sure that the accelerometer, or the IMU basically, is also working in this display. Well, there's one more interesting code to test out the IMU on this display shield, which is provided by Arduino community, of course. And here is that code, and here I'm going to provide the Arduino Logo.c file as well. Well, I'll be providing these both files in the description of this video, and make sure Arduino Logo, this INO file, and this .c file must be in the same folder to make this code work. After that, make sure you have installed all the necessary libraries and just hit the upload button. In my case, I already uploaded the code, and let me show you the visual demo of it. So I'll turn on my smartphone screen, and so here is the Arduino logo, and as you can see, the logo is is stabilized with the help of the IMU. So even if I move the display, the orientation of logo is not at all changing, or rather it is adjusting based upon the orientation of the display. Okay, and I can shake it as well, and as you can see, the nice little kind of animation is happening here. So with this we can test the inertial measurement unit or IMU on this display shield. A very interesting example code. Now let's start with the most interesting feature of this display, that is the LVGL support. Now for those who don't know about LVGL, then it stands for Light and Versatile Graphics Library, which as its name says, it's a graphics library, an open source graphics library used for this kind of microcontroller boards to create some amazing graphical user interface on this displays. Okay, so Arduino GIGA do support it, and we do have a couple of examples provided in the Arduino ID. So let's check out the example codes and let's see what kind of user interface we can create. So I'll go to the files, into examples, then into Arduino H7 video, and here is the LVGL demo, and straight away hit the upload button after selecting the right COM port and board. Okay, so the code is successfully uploaded, and on the display we can see some amazing graphics. So we got a grid-like structure in which we have 4 boxes. The background color is of Arduino blue, and on the top left corner we get the Arduino logo, and in the next block we get to see a couple of buttons which are clickable as well. So I can select apple, I can uncheck this banana, I can select lemon. Okay, so we have radio buttons, we have checkbox buttons, and here we have click me button in which the number is incrementing based upon the clicks, which is quite responsive. Then here we have slider that says drag me, and it's a very smooth slider, useful for dimming the fan and dimming the brightness and stuff like that. And here in the last block we have the animating bar, that is kind of a progress bar which we can use to show the temperature, the humidity, or maybe the loading animation. Okay, so this is a very basic code, and we can scroll up, scroll down as well. Okay, it feels like a smartphone. Of course there is like a glitch, it's not that smooth as compared to the smartphone because of the frame rate, but it's smooth. It's really smooth and compared to the other displays. Okay, so we can scroll up for adding more widgets and stuff like that, and this is the basic example of how powerful the LVGL library is. So we can create some amazing graphical user interface, and all this is made using that library, and of course by writing the code for it. Now to understand how you can make all these things, well, Arduino do provided a guide, so let me show you. So here is the GIGA Display Shield LVGL guide by Arduino, in which they have explained each and every line used in the LVGL code, like how to initialize the display, how to initialize the touch, everything they have explained in quite simple manner. Okay, so what they did here is they have made a separate code for all the 4 functions that were shown in this display. So in this display it shows the image, the checkboxes, the buttons, the slider, and the bar animation. So all these codes are shown separately and explained as well. For example, this is the minimal example code that will just show the grid, like 4 grids on the display, which will look something like this. After that, they have shown how to add the image into that grid. This code is here. After that, they have shown how to add the buttons, whose code is provided here, and after that they have shown how to add the radio buttons, then how to add the slider, how to add the bar. Okay, so all the examples are provided separately in this page with the proper explanation. Now this guide only limits with 4 or 5 widgets, but don't underestimate LVGL. LVGL is way more powerful than adding these 4 widgets. So if I show you the official documentation of LVGL, and here if I go to, let's say, examples, and then into widgets, as you can see, these many widgets you can use. You can use arc, bar, button, button matrix, canvas, calendar, line, LED, label, spinner. There are a lot of widgets, and not only they provide the widgets. For example, if I want to add the keyboard, I can select the keyboard, and they have also provided the C code and the MicroPython code to add that keyboard into your display using the LVGL library. So there is an amazing documentation. I will provide its link in the description, and by going through this documentation, I have made my own two different kind of codes compatible with the Arduino GIGA display. Let me show you that example codes. So the first code is about adding 3 different buttons to control the RGB LED on the display shield itself. And here are the declaration of all the 3 buttons. So I have one for red, one for green, and one for blue. And with those buttons, I can control the LED. So I already uploaded the code, and let me show you its demo. So here are all the 3 buttons, and I can click on red, the red will turn on. I can click on green, the green will turn on. And if I click on blue, the blue will turn on, and it is quite responsive. And that's how you can use the LVGL library and the documentation for creating such graphical user interface based projects. There is one more example which I took from that same LVGL documentation, and it is about the AZERTY keyboard. It's kind of a different version than the QWERTY keyboard. So let me just upload this code and let you visualize what is this about. Okay, so code is uploaded, and as you can see, we have a fully functional keyboard on the screen, and I can type the letters like AZERTY. I can also use the backspace to delete it. I can also press enter to go to the new line. I can also, like, there's a cross button, that is a check mark button if you want to add couple of events. Okay, you want to submit this words type here, and I can also use space and colon, and there is a fully functional and responsive keyboard, and this all made using the LVGL libraries. So now you kind of got idea about what LVGL is all about and how powerful it is for the GUI projects. So these were only couple of examples, but you can try out many others. Well, now there is one more thing which I need to discuss, and it's about the Square Lin Studio. Now for all those who don't know what the Square Lin Studio is, then it is a part of LVGL only, in which you don't need to write code to make the graphical user interface. Rather, you can use the drag and drop method, add the buttons, add the labels, add the colors, everything in that software. And once you're done with the graphical user interface, you can click on the export button. It will write the code for you, which you can use later on in your Arduino IDE. So no need to write the code for setting up each and every widget. Now that is an amazing platform for sure, but currently I'm not able to figure out how to use the Square Lin Studio with the Arduino GIGA Display Shield or Arduino GIGA R1 Wi-Fi board. But soon I will try to figure it out, like how these two things work, and maybe I can make a separate video about it, because definitely Square Lin Studio do deserve a separate dedicated video, because it's a very big thing, and it will be really very useful for all the GUI based projects. Now this GIGA display do have one more very interesting feature, which is the 3D engine. So yes, this do have a 3D engine that help us to construct and render 3D objects on it, and this uses the library called as TinyGL to make all this happens. Okay, so they do have provided two examples, like the 3D gears and one more gears plus example. So let's try out those two example codes, and let's see how it looks like, how 3D objects look on this display. So I'll go to the Arduino IDE, and here of course you need to install one library called as TinyGL using the library manager. And once you install that, you can go to files, into examples, then into Arduino TinyGL, which is here, and here we have two examples, gears and gears plus. So let's try out the gears example first. So here in this 3D engine tutorial, they haven't provided a detailed explanation about how each and every line of this code works and what it meant for. Rather, they have explained only one or two different functions. So it's really difficult to understand the code, but it is what it is. So the code started uploading, and the code is successfully uploaded. Now let me just turn on the smartphone's camera. So yeah, we have 3 gears, and I can interact with all the 3. So I can, change its orientation. I can zoom it out. I can zoom it in as well using the 2 fingers as much as I can. Wow, this looks amazing. I can zoom it out, can rotate, and yeah, this is the 3D object, like 3D gears displayed onto the GIGA Display Shield using TinyGL library. Looks really amazing in real. Let's try out another example code as well. So I'll go to the examples, which was gears plus, and I'll straight away hit the upload button here as well. Okay, so the code is uploaded, and here we don't see any gears, rather we see a robot coming in front of us. Let's try to interact with this robot. Okay, so I can change the angle. Okay, so I can, oh wow, this looks really amazing. Let's just try to zoom it in and zoom it out. Okay, so I'm able to zoom out a bit. This looks really amazing. Let's just zoom it in. Okay, so I can zoom it in, and I don't know where am I right now. So yeah, this is the 3D gear plus example code provided by Arduino community, and only these 2 examples are provided for this TinyGL library for using the 3D engine to construct and render the 3D object. But this opens up a lot of possibilities. Of course, the documentation is not properly provided, but we can explore the TinyGL library and try to understand each and every line of code to make our own 3D objects. So that was an amazing feature. So that was the GIGA Display Shield, and it's truly more than just a display. So do hit the like button if you really like the display and the video, and let YouTube algorithm know that this video was good and worth watching. Well, the LVGL part of this video is something that excited me the most. I'm looking forward to learn it more deeply, and after learning that, well, I may make a complete home automation dashboard on this GIGA Display Shield to control my whole studios. But if this is something that excites you, well, do hit the subscribe button, as I may upload that video in the upcoming Sunday. So yeah, do share your thoughts regarding this display down in the comment section. And yeah, that being said, I am just ending this video here, and now just wait for my next video. Until then, explore, learn, share with me, techiesms.